Does it work? Yes, because now it works. Yes. All right, we are 1 minute out, right?
Hi, hi. Does it work? Work? Ah, yeah. No.
Yeah. Now you can sing.
I did that to you.
Exactly. All right. We are almost there. I could be a DJ. 8:59. All right, it's 9.
Let's start and
Do we want to start?
yeah.
Welcome, everybody. This is a heat reuse presentation and panel. We're going to start with a brief introduction of what Jaime and I have been doing for the last, 18 months?
Yeah, more or less.
Yeah. So 5-10 minutes presentation, no more. I promise you, not many slides. And then we're going to have a panel, and maybe, guys, you want to introduce yourself?
Sure. John Gross with JM Gross Engineering. I'm a MEP engineering consultant based out of the US.
Mike Truong, I'm with Equinix and lead the Linux Foundation Open 19 project.
Hey, good morning, everyone. I'm Dharmesh, Jani, DJ from Meta, and I support partnership and infrastructure team in Meta.
And Jaime, you want to introduce yourself?
Yes, and I'm Jaime Comella. I am co-lead together with Cosimo of the heat reuse sub-project at the OCP, and I'm the data center architect at EQ Compute, which is a new colocation brand we are creating in Europe, and that aims to build net zero data centers.
And I'm Cosimo Pecchioli with Alfa Laval, and if you don't know Alfa Laval, shame on you. And it's we do cooling systems for the data centers and all kind of, let's say, solutions from liquid cooling to air-cooled servers.
Good. Then thank you for being here, first of all. So the heat reuse project started around, we said, 18 months ago. We have meetings every second Tuesday at 5 p.m. CT or 8 a.m. PT. So there's our wiki page if you want more details. We are part of the Cooling Environments project of the OCP. We have had so far 18 guest presentations, so people coming and telling us about their use cases with heat reuse projects in data centers. Otherwise, we have regular discussions calls, and we discuss about the works that we are actually doing. So we have an article under revision right now, which is the 101, and we'll briefly talk about that just right now. We are elaborating guidelines since a long time, but since there are guidelines, they are longer and takes more time. We already have a heat reuse map online that you can check, and it's a live map. I mean, it's an ongoing work.
So the heat reuse 101 is, as soon as we started having presentations, the way we work is actually we realized that for our audience is beneficial to hear from real cases. So data centers that actually implemented heat reuse already. So as soon as we started having these presentations, we realized that it would be helpful to have a concise document about heat reuse and what it entails, what you would need, and what options you have. And so we started with a longer version, which are the guidelines that Jaime will talk about in a few minutes, but that is a very long document. It's like 40 pages. And we said, well, we cannot really bother people with that kind of document. So we try to concentrate that in a 4 or 5 page with a lot of pictures document, and that is the heat reuse 101. It was actually supposed to be published before this conference. Unfortunately, we didn't make it. But if you click on that QR code, you have access to the preview, and there you have what again is the heat reuse 101. Very basic principles about what heat reuse would entail. The other project that we have been working on, actually this was Jaime ideas, to be honest.
Oh, thank you.
Is to put together a heat reuse map. So as we said, we have been having presentations during our 18 months of real cases. So why don't we literally put those cases in a map? And if you actually click, this is how the map looks. Can I have the pointer? And so each dot is a project that you can click, and the red dots are projects that are in construction, and the blue dots are actually projects that are actually running already. And of course, again, the QR code is the link to the map. It's available to everybody. It's accessible to everybody. And we welcome any kind of feedback. If you are part of those projects and you see a mistake, please let us know. If your actually heat reuse project is not in the map, let us know, and we can definitely add to the map. The step farther, we realized that with the map would have been important is to have a standard set of information across all the projects so you can compare them, first of all. And then if you have in mind actually heat reuse opportunity, you can say, okay, let me see a similar climate for where I am. Let me see if there is an existing project. And so you can kind of learn from other people or contact them and swap notes.
Just one thing you see there is like 7 US use cases against 61 in the EU. So also we had the help there of the Dutch Data Center Association, which was very helpful.
Yes.
So everyone that knows the project, we are more than welcome to input there. So there are most probably more projects that we don't know. So
See, probably you have noticed that the presence is a little skewed toward Northern Europe for a good number of reasons. That we will talk about later, but unfortunately we don't have, and most of these projects that we have actually in the US are either like universities or they're kind of smaller size heat reuse examples. So unfortunately, I'm based in the US, even though I'm from Italy originally, but Europe is running circles, literally, around the US. So these are the information that will be available. Of course, collecting information is never easy. People tend to be pretty private, but we are trying to get as many information as possible. And the other document is
the guideline will be very brief here because we are running out of time before the panel. So the guideline is the extensive document. I mean, the OCP is there also for guidance mostly. So that's why we started this document. We want to put there also calculations, financial calculations and technical calculations that can be very useful for new developers. And that says some details about, for example, emissions, temperatures, and so on. So this is also a document that is growing. You are all invited to contribute to here, either in our calls or just offline at home if you want. And you're more than welcome to participate. And then future work, we will continue with our guest presentations that sometimes are very, very popular. We're having sometimes 90 people.
Always very popular.
Very popular. And well, next jobs is a checklist, which would be kind of an assessment or, like trying to make a score how your data center will look like for heat reuse. Based on certain parameters that we are defining. Again, you're more than welcome to contribute to that. It's still in shape, under shape, so you can actually tell us what you would like, because at the end, this is a tool for the industry. It's not for us. And the last point is something that is being already developed by some people, actually here in the present as well, is to contribute to this matchmaking platform, which will be a place where heat producers, so data center heat producers, and heat off-takers or heat users can meet each other, because we see that's one of the biggest hurdles.
All right, so let's start with the panel. So the first question, Jaime, of course, it's for you, and John, you will be involved in this question as well. The first question is heat reuse. Why heat reuse, and why now?
Well, I think there are 3 main reasons. One of them is like, it makes sense. At the end, it makes sense not to put more energy, to remove energy, and this makes much more sense to just give it away to somebody that is needed. It's like a moral duty as well. The second reason will be all the new policies and regulations, so new policies from big tech companies, such Meta that we all really embrace, and because they're driving in the right direction. And the regulations, we are now in Europe. I mean, Europe and the Green Deal, European Green Deal, is pushing this forward. There is the EU taxonomy, which is defining how sustainable is an activity, so we can all talk the same language and define how activities are sustainable. This will touch almost every big company in Europe. They will have to do that at some point. And one of the parts, I mean, they are referring the EU Code of Conduct, the Data Center Code of Conduct, which is a bunch of best practices where the heat reuse is there. It's now as optional, but will probably be necessary to be taken. And as an example, Germany is now at the forefront of these changes. It's still a draft, but it will be probably a law soon that says that 10% of the energy of a data center will have to be reused, and this will change the map. So I mean, you will be forced to do that in Europe, for instance. And the third reason is the rising of the liquid cooling, probably, that will push that.
So on your opinion, is liquid cooling, its heat reuse necessarily, let's say, bound to liquid cooling? What's your...
So it's not bound to liquid cooling, but liquid cooling definitely makes the heat offtake from the heat source quite a bit more effective. And the other thing that comes along with this is that the quality of that heat that comes along with it can be quite a bit nicer than using your heat dissipating through air and then running through an air conditioning system. So quality of heat is really the important piece here of how high can you get that heat before you put it into a heat network without expending additional energy inside of a heat pump to bring that heat level up. Yeah. Depending on the heat network that you're operating in, we've seen something as low as 65 C. We've also seen heat networks all the way up into the 190 C. So there's a lot of variety in the heat networks. But as you need to bring that temperature up, so if you're having an outlet temperature at 50 C, bringing that temperature up a number of degrees requires a series of heat pumps to really bring that temperature back up to become useful.
As a spoiler alert, in the Heat Reuse 101, you will see that actually opportunities for heat reuse are different. I mean, there's not only human comfort and district heating. So, John, you have been working actually in one of the few US projects that actually is considering heat reuse. What's your experience?
Yeah, so from an engineering perspective, human comfort sounds great, right? When you actually look at the loads and you look at the load profile of the heat that you're generating versus the heat host, it's not really a great match, right? So the better match is where you get a higher percentage of offtake from your heat is actually going and looking at process loads, right? And so the particular project that we're looking at, it's a process load, but it is also still tied somewhat to the ambient, and it's for indoor farming. And you talked about why would we do some of these projects, and there's a couple of reasons in this particular case. So the project's located in Wyoming, and it's in southwestern Wyoming near Salt Lake City. Salt Lake City gets all of its fresh produce from California. Problem is that's a 12-hour truck drive through the mountains. And so the produce is a little bit older when it gets there. There's a lot of refrigerated warehousing on the way. There's a lot of fuel consumed on the way. Southwestern Wyoming is an hour and a half away, but it's too cold to consistently farm and generate produce. It's also, the energy cost is such that it's not cost effective to do indoor farming using utility power to generate the heat for the indoor farm. The heat that's being produced by the data center is this whole network is being co-developed, right? So the farm is under development, at the same time the data center is under development. One of the key things is that allows us to actually synergize the heat network, right? So we're telling them the grade of heat that we're able to provide. They're designing their heating systems to be able to consume that heat. So we can really optimize that. But what it allows is for eventually a 30-acre or 12-hectare indoor farm to be created that would not otherwise economically be viable, and it's going to be able to supply the fresh produce to Salt Lake City, and every single truckload is a savings of 1.5 tons of CO2.
That's great. And DJ, this sounds a lot like circular economy, decarbonization. How does heat reuse fits into? Yesterday you had a fantastic presentation about Meta and your goals, and what's your take in this
Yeah,
conversation?
so I wanted to start by touching on the previous point, which is why is this problem becoming interesting at this point in time? And there are two primary reasons we see. One, the scale is going up in terms of the size of data centers, obviously. And the second, the power per compute is also going up with AI and everything. So for every technology and every use, there is actually a certain barrier. Once you go over that barrier, that becomes a viable solution. And hence, heat reuse, we are reaching that point in time where it becomes viable to extract heat. So that's the first point I wanted to make. The second point I wanted to touch on was John mentioned, which is about network of ecosystem locally, which is very important for ensuring that these ideas can be implemented in a manner which are accretive. If you have to create these networks from start, then of course your barriers are higher. So, in Odense, for example, Meta works with a local company which actually is involved in distributing heat to the homes. And we provide our heat to that company, and then they incorporate it with their own structure, and they pass it on. So that exists very similar to the farmer's environment which John mentioned. So that is existing, and hence it becomes very easy. Now, coming to your question of how this looks like circularity. Actually, it's an interesting question. We should, at this point, start thinking of something which I say as heat life cycle. We talk about product life cycle all day long. We talk about equipment life cycle all day long. It has a birth, it has a time of operation, and it has a sunset. Why can't we think of that for heat? Absolutely, we can think of that as a heat. Heat has a birth, heat has a purpose, and then heat sunsets into dissipating into atmosphere. Using this analogy, how about we extend the life cycle of heat, just like you are extending the life cycle of a product? You can start thinking analogically now. You can do product circularity. Why can't you do heat circularity? Once you think in terms of those life cycles, then it becomes very obvious that at some point it makes sense. So the circularity here applies in terms of extending the life of heat usefulness before it gets dissipated with second law of thermodynamics and entropy. It becomes irretrievable. Are there ways to extend it? And I think we are reaching that point because of the factors I mentioned earlier, where the extension of the life is exactly like circularity. And anything we extend, we are only going to reduce the carbon footprint. So that's how I think of it.
And of course,
I'm sorry, if I could add on to that. So one of the things that we focus on a lot with heat reuse is the servers are generating heat from power and whatnot. We're taking the heat out of the data center and we're sending it off to somebody else, right? Jaime, you mentioned earlier, you give the heat to somebody else. No, you don't. You sell the heat to somebody else. Yeah. So first of all, you're monetizing your capital investment to create that heat network or interface with that heat network, right? So in the case of the facility we're working on, it's a co-location facility. The tenants are actually going to get a credit back on their bill for the heat that they're producing and the grade of the heat that they're producing, right? So there's actually a financial return for doing that heat offtake. But the part that a lot of people also don't talk about is if I don't send that heat to a host, I have to reject it. I have to spend energy to reject it. So I've got a closed loop cooling system, and somewhere in that closed loop cooling system, I'm sending heat out that otherwise would go to my heat rejection plant, my cooling plant. And so my electric bill is coming down on my cooling plant at the same time that I'm getting paid to send that heat to somebody else. So I'm actually getting paid twice.
And that heat replaces another form of energy to generate that heat.
Exactly.
So it's three levels.
Right. But it goes back to what DJ was saying about the heat circularity, right? Yes. So there's a circularity. The heat has left the servers and it's gone over to a host over here. But also in my closed loop, circular, I'm reducing the load coming back. Okay. So I actually have two benefits there on the circular economy related to that heat reuse.
So
let me throw
Yeah,
one more onto the
I
end
actually,
of that.
I
Let me
was about to
throw
ask
one.
you yours.
Yes. And depending on what that energy source is, if you're coming from a green energy source, it actually helps us start to decarbonize those heat networks. So those heat networks are classically coming from a very uncarbon-friendly power source. And so as we think about taking that heat and rejecting it, if we're getting power from a green energy source and decarbonizing the heat network itself, it's actually a benefit for everybody.
And Jaime, you are the only European in this panel.
Yeah.
So, but you are in the process of actually building the data centers in Europe, right?
Yeah.
What's your, because the problem that we have in the US is that normally when you select the location, you look at a lot of different factors in selecting a location. Heat reuse is definitely, it's not that it's low in that list, it's not in that list.
Yeah.
How about your experience here in Europe?
Well, it happens the same here, pretty much. I mean, to consider heat reuse is a very novel thing. And it's quite complicated because it's already complicated to find a suitable plot, big enough, with a good price, with enough power for years, with fiber. And on top of that, it needs to be close to someone that needs the heat. So this is a challenge. And now we are developing a data center close to Barcelona, and there is a district heating there. And even in that case, it's very difficult. I mean, we'll need to talk to different politicians at different levels, to the neighbors, maybe to the university. We may get across the street. And the district heating network is quite old already. So there is a lot of challenges. And that's why we need this matchmaking platform, because we need to be able to sit in the same place, in the same bar even, if we want, different actors from different sectors. I mean, we're not used to do that so far. I mean, at the end, it's an intersectoral collaboration that is needed. Otherwise, this will be very difficult. And if we're going to be obliged to do that by law, then we'll definitely need that.
So Jaime, I love the conversation you're having there about going out and looking for the heat network, looking for your neighbors, and so on and so forth. If you take, this is part of a presentation that I've done several times. So if you take a look at the typical data center developer mentality, when you go and you look at your neighbors, when you're doing site selection to build a data center, right? A lot of times you're looking for fiber, you're looking for power, and you're looking at your neighbors, but you're looking at your neighbors from the perspective of risk, right?
Yeah.
How risky is it to be around these neighbors? If you're going to enable heat reuse, you have to look at it, okay, fine, they're low risk, great. Are they a potentially good partner for heat reuse? You have to really change your thought process when you're looking at development.
But what if they are not neighbors? You have to go where they are neighbors, or you have to partner with somebody. I mean, sometimes we think it's very easy as a district heating, but sometimes it could be a brewery, an industrial laundry, a pharmaceutical industry. And
process loads. You're looking for process loads to the best of your ability.
Exactly.
And then there's another challenge that the DJ and my the challenge of a medium and small size company compared to the size of a multinational corporate like the ones that you work for are a little different. So how do you see this? Because unfortunately we realize that one size fits all in heat reuse doesn't exist. So every location will need to be kind of customized. How do you think that is manageable?
So this is my personal opinion. It is a challenge.
Yeah.
Like everything, you don't go and do things which are suited for one size of organization. Not every other size of organization should follow that. So my personal thought is that we have to look at the biggest problem, biggest sources of heat as a place to harvest. You could have many points where your heat generation is not as large, and you kind of go and implement these kind of processes, and you find that you don't get as much out of it at the end of the day, right? So you build a dam on a river where there is enough flow of water. You don't go and build a dam on every little river. And you have to choose the site of dam very, very carefully with the right amount of height, and then you have to calculate geothermal energy potential, and then you go and decide, can I invest $10 billion or whatever to build a dam? Same thing happens with something like heat reuse, where you don't go and start looking at heat reuse in every situation. you have to probably do similar analysis. You have to do probably a similar modeling. I think somebody mentioned that you guys are working on a modeling in the heat reuse sub-project within Open Compute. So perhaps we have to do some of that thoughtfulness. Maybe what that leads to is there is an opportunity for smaller set of folks to come together to now have a bigger portion of heat to extract. And that leads to network, that leads to matchmaking, which you talked about. So that's where the potential needs to be explored. And then I do believe that policies and governments, you mentioned about Germany, that also has a role to play. So it's a kind of a complex problem, but we start by addressing areas where it's simple first, like in Odense, Meta recovers or reuses 100,000 megawatts of heat, which powers 7,000 houses. Now that's a number which is worth going after. So you have to start with some big areas like that. Meta doesn't go and do heat reuse everywhere. We start with one particular site, do the pilot, and then figure out what works, what doesn't work. And I think that is probably a process which I believe is going to evolve over the next 10 to 20 years. Yeah. And then 20 years from now, probably we'll be at a point where it would be such a common structure, right? And most of the technology develops, right? You look at road networks, you look at anything, they develop in some main areas first, then branches develop, and then it becomes ubiquitous. So that's my personal opinion.
And I actually have a two-part question for you. So my understanding is that Equinix is pretty committed in looking for heat reuse in Europe. Yes. So first, I would like to comment about that first. And second, when do you think that is going to happen in the US?
So let me answer the first question. So Equinix is definitely committed to heat reuse in Europe. We announced the Paris 10 site is using the heat from that particular site as part of the heating infrastructure for heating the Paris Olympic swimming pool in 2024. We have similar exercises inside of Helsinki and the Nordics. The Nordics are very easy to go find heat networks and distribute heat. And as we start looking across Europe, we have this opportunity where we have many megawatts of heat that we're happy to go and help communities with heating infrastructure. So finding a heat network and plumbing it, it's just a matter of like how close are we to the heat network and is it economically viable, as John was saying, is it economically viable or incentivized in such a way to make that work? Now in the US is a little bit more difficult because the geography itself is a little bit more spread. Large metros don't exist. Putting a data center inside of a large metro usually does not financially make sense for most organizations. Mm-hmm. There's a lot of legacy telco style builds that exist in some of these metros, but the size of heat and the quantity of heat that we're talking about there is actually relatively small. Now, incentivization structures in the US are not really organized in such a way that is advantageous for data centers to go produce heat. So local to me, I'm in the Bay Area. We have a very large San Jose campus, and adjacent to the San Jose campus is a large community of apartment complexes and dwelling units, and that would be a perfect place to go deposit heat, but we have not organizationally and governmental structure incentivized taking that heat and not doing something but dumping it into the atmosphere. So there's a large incentivization structure that doesn't exist in the US and actually outside of Europe. And APAC is also a generally similarly structured organization. So,
and I would add on to that. So in general, you look at renewable energy or you look at energy savings projects, right? The US has always lagged behind the EU and APAC. And one of the fundamental reasons why, outside of the fact that there's the lack of government incentivization and regulation, is the ROI, right? Yeah. So, I mean, Jaime, you live in the EU. If you don't mind sharing, about what's electric rates right now?
Well, it's skyrocketing, yeah.
Right.
It's depends on the country a lot, but it will be more than 25 cents per kilowatt hour.
Right. So in the
US is what, 4 or 5?
Right. So in the U.S., in Texas, for example, commercial accounts are paying between 4 and 5 cents a kWh. So developing an ROI off of that is very, very difficult. So if the government's not forcing you to do it and they're not giving you tax incentives to do it, and you don't have a corporate structure that basically says, I'm going to do it for good PR and so on and so forth, if you've got accountants sitting there looking at it, it's hard to come up with the ROI. Yeah. So that's why, you know, the big effort, at least in the projects that I'm involved in, is to look for those process loads. Because when you look at those process loads, you have a higher percentage of offtake. And with that higher percentage of offtake, it helps with the ROI. The other thing I was going to mention, and this is something that a lot of people don't like to talk about with
so
regards
let's not
to
talk
heat
about it.
So, you know, but when we look at these things, right? And DJ, you mentioned, you know, you're looking for partners, right? And you've got to look at what you know, what partners around you need heat, what grade of heat do they need, so on and so forth. The chip wars right now that are going on are driving the TDPs up, which are also driving the required T case down. Right? As the required T case goes down, that means that the loop temperatures are going to start to drop over the next several years in the data centers, which is going to compound the challenge of doing heat reuse. Doesn't make it impossible. It just means you have to think more ahead about who your partners are going to be, co-developing to work for a specific grade of heat, and planning for scenarios where maybe today you can take the heat off of your ITE and you can send it directly to that heat host without having an interposing heat pump to boost the grade of heat, but plan for the ability to add that type of infrastructure in the future to sustain that heat host over the next 20, 30 years.
Yeah. So I actually have a number of questions, but we are running out of time. So before I ask my questions, question from the audience, you can, there are 2 microphones there on the side, you can.
Oh, here we go.
I know that this part from AMD. I know the epicenter is kind of Europe in this. What are and U.S. is a smaller market that's evolving. What are you hearing out of Asia? I mean, they've already got pretty large-scale liquid cooling today, so that's an easier medium to do the heat capture. But from your group, are you seeing interest from that area and India also?
There is one project in Japan in our map.
But I would probably let the international companies here to answer that question.
So we definitely see interest in Asia, depending on what part of Asia you're referring to. And if you throw Australia into Asia, like everything starts going off the rails a little bit. So there's definitely interest there, and it just depends on like the geography that you're talking about.
From just to kind of follow on, from the broader heat reuse meetings, are you seeing any participation from like Asia or China more specifically? With
that's a problem because Asia is Singapore and Asia is Mongolia, right? Yeah. So, and heat reuse, of course, is heavily dependent on the local climate. So in Singapore, where it's hot and humid almost year round, heat reuse is challenging.
Well, we'll have a presentation afterwards from Peter. He will, I mean, I think you could get an answer about that, probably.
So I'm sorry, but you have to endure another presentation.
So Cosimo, if I could add, so when we talk about thinking outside the box a little bit, right? The traditional concept for heat reuse is going to be heating air. It's going to be providing process heating for farms, indoor farms, and so on and so forth. There's other heat reuse cases that are not outdoor ambient dependent, right? Desalinization. Desalinization is a great one. Now, the problem is desalinization requires high-grade heat, right? But that doesn't preclude it from being hooked up to a data center for heat reuse. Yeah. So for anybody out there that's developing data centers, regardless of where you are in the world, developing data centers and you're looking at heat reuse cases, I would ask you to look for any opportunity where there is a process heating load nearby that you can tie into, whether it's ambient dependent or not.
Yeah. No, it's a good point because, and I'll let you ask your question in 10 seconds. Immediately people think about human comfort when it comes to heat reuse, but industrial laundries, biomass drying, dehumidification, that there are...
Foam injection.
Yeah, which by the way are 365 24/7. They're not seasonal. But even if they're seasonal, we don't need to aim at 100% heat reuse year round. Even if you use 20%, 15, 25% of their heat, it's 25% of megawatts that you take out of carbon emission heating sources. So, I mean, let's start somewhere. Sorry, John.
It's John Summers from Research Institutes of Sweden. So, first of all, I'd like to make a comment. Let's look at this. Let's look at the optics of this. First of all, electricity is 15% of primary energy source. Data centers are around 1 to 2% of that, so we're talking about 0.3% of. And why are we still focusing on this when they're so important to the economy? So this, I think this is something that we should really think about. You know, there are so many other aspects of society that need decarbonization. You had a program for Panorama in the UK saying the cloud is killing the planet. You know, the optics are all wrong. So I think, you know, we need to take a step back and look at this from a better perspective. Okay, data centers are very difficult to understand. We can blind the public with the science. But the thing that I think that we need to be careful of is the fact that you've got governments now, in the EU, I've just read today, that they are mandating, they're going to mandate from May 2025 that if you have a 1 megawatt source of electricity to your data center, you have to reuse the heat or show that it's technically not possible or economically not possible. The other thing is that the Energy Efficiency Directive, which the EU is pushing down, talks about these metrics, the ISO metrics, and I think whenever we use PUE, we should always say it's an ISO PUE, not anybody else's PUE, the PUE that has to be dealt with by the ISO, and there are standards, you know, this has to be done properly. But what's interesting, and one thing that I've never really been able to get a good answer on, is if you put a heat pump in the loop, if the heat pump is owned by the data center and providing cooling to the data center, the boundary conditions for ERF, which is the energy reuse factor, say that the energy has to cross the boundary of the data center. If you use it inside the data center, you cannot claim any heat reuse. So it has to cross the boundary of the data center, but then your PUE is not going to be as good as it should be, and you've got people who are coming to you and saying, sorry, I can't host with you because your PUE is too high. How do we deal with this?
Well, I mean, we all know that PUE, we are all grateful to PUE. It was absolutely instrumental, but it's an old metrics. So we need to move, we need to use PUE, but move forward, in my opinion. I don't know.
Yes,
I don't want to speak for my panel.
I have mentioned this last year at the Global Summit. In one of the ways we have to move forward, I mentioned it yesterday. I think we have to move beyond PUE. What happens if your PUE is already 1.05?
Yeah, I mean.
Now what do? Do you achieve success and say we are all done? No, not at all, not even close. PUE, okay, I have to tell this story. You know, growing up in India, you know, like many of you here, parents, you know, I would move from one room to the other, keep the lights on. Suddenly, magically, my father would appear from nowhere and slap me on my head and say, turn the lights off. Mm-hmm. Everywhere that's what he would be doing. And do you think he was worried about being green or sustainable? No. He was worried about his pocket, electricity bill. He didn't care about, you know, efficiency. But guess what? In that process, he's increasing or decreasing the PUE of the house. But that's because he wants to save money. PUE is common sense. It's saving money. PUE is nothing to do with... I just don't know when PUE became attached to sustainability. I've been trying to talk about this in sustainability all the time. People say, oh, what are we doing for sustainability? PUE. No, PUE is you're saving money. You know, you'll always say, like, turn the lights off because that's going to reduce your electricity bill. It has nothing to do with sustainability. It is to do with your bottom line, right? So what are we doing for carbon? I don't know. Okay, so that's what we have to measure. And I think that's not an easy problem, which is why we have to find a way to collaborate and figure out a new way. And I do agree with you completely, and I mentioned my point earlier. Heat reuse is not something which you have to, just because one person is doing doesn't mean another person, everybody has to do it. It may not make sense. Actually, it will not make sense to do heat reuse in Asia, in Singapore, where temperatures are hot and humid. People will laugh at you and say, okay, you know what? They don't even have hot water in the tap. In fact, they want cold water. So what heat reuse we are talking about? So the possibility goes down, right? So it would be awesome if all of you and brilliant people in the industry can start thinking of heat reuse as a geothermal equivalency analog, and then say, okay, which are the areas on the globe where heat reuse can matter? Now, somebody talked about data center and why you cannot tap into that or whatever. Whenever data center site selection is happening all over the world by companies, nobody thinks of heat reuse as one of the factors which should go into the data center selection. Not one.
Not one.
They talk about local electricity cost and stability of the government and privacy. And hence, in Asia, do you think they would have a big data center in some random country? No. Why? Because of regulations, right?
I mean, who wants to invest 1 billion in a country?
Yeah, so then somebody will say, why are we not doing heat reuse in Asia? Well, there are no big data centers in Asia because of not heat reuse, something completely unrelated, right? Yeah. So I think we have to change the framing in the way we approach this, is what my thought is.
So we are actually running out of time. We are a few seconds. As you can imagine, this is just the beginning of the conversation. I strongly encourage you to join our group, and we can have this discussion for the next 25 years, probably. Thank you very much.
Thank you.
Thank you for joining.